Hi. I've had a couple of questions regarding 7 and 8. And where the question's coming from is students are having trouble figuring out whether we should do 22 minus C or C minus 22, because and it does matter, obviously more for subtraction. For addition, it's not actually going to make a difference. But if we think about this, 22 is the speed the boat's traveling, 22 miles per hour. So it makes sense that we will take the current away from that when the boat is traveling against the current, which would be upstream. And then it will add C when the boat is traveling downstream because the current is speeding it up. And so the reason why we do this, if you think about this, the vehicle, whatever the vehicle is traveling faster than the speed of the current. So vehicle could be a bike, it could be a boat, it could be, I don't know, a person, like if they're jogging into the wind. And then it's going to minus or subtract or add, depending which way it's going, if it's going into the wind versus if it's going with the wind, the speed of whatever current we're talking about, be it wind or water. And again, if you're adding, it doesn't actually make a difference, but the subtraction is very important because obviously you'll get a very different answer. So to go back to this question for just a minute, we have, a boat can travel 22 kilometers per hour in still water. The boat travels 18 kilometers up a river and then 18 kilometers back down. So we have up and down. I don't know if you guys can hear my kids in the background. They are very loud. I wanted to do this really quick because I know some of you guys are probably studying right now. So 18 up and then 18 back down. And so for the rate, it's the rate that the vehicle is traveling, either plus or minus. So as it's going upstream, the vehicle is going 22 miles per hour and the current is slowing it down. So the rate is lower, the rate that it's traveling. If it helps you to think about it as speed, maybe you have a better mental understanding of speed. So the speed is slower when it's going against the current. So 22 minus C. And then it speeds it up when it goes with the current. And the time will always be the distance column divided by the rate column. So 18 divided by 22 minus C, 18 divided by 22 plus C. And then there has to be something that is relating the times. The entire trip is 4.2 hours. So if I add those, I get 4.2. And then from there, you can multiply through by your LCD and solve the equation. Make sure you give me some units with your answer. All right, the next one, obviously this is a very different question. It says Marcus can empty his swimming pool in 2 hours if he uses both of his hoses, which have different diameters. Using only the small hose, it takes 3 hours longer to drain the pool than when using only the larger hose. Write an equation that can be used to find the time t that it takes Marcus to drain the pool using only the larger hose. How long does it take Marcus to drain the pool using only the smaller hose? So in this case, our three situations are small, large, and then the together rate. And then remember, the equation is going to be the sum of the individual rates will equal the combined rate. So it says Marcus can empty the swimming pool in 2 hours if he uses both of his hoses. So together, the time it takes is 2 hours. So that means the two hoses fill half the swimming pool per hour. So the combined rate is half a pool. I cannot make a straight L for some reason. Pool per hour. There we go. Using only the smaller hose, it takes 3 hours longer to drain the pool than only using the larger hose. So if I make the larger hose X, it takes 3 hours longer to only use the smaller hose. So the amount of time for the smaller hose would be X plus 3 hours. Then, so something to make it, does this make sense? So for instance, 5 hours, suppose, I'm just making this up. So suppose it took 5 hours for the large, then it would take 8 hours for the small. Logically, that makes sense. Now, granted, that's not saying the correct answer, but you can kind of think through, do those values make sense for the problem? Well, they do, because the larger diameter hose should fill the pool faster because more water can travel through it. So the rates are 1 over x plus 3 and 1 over x. So to write the equation, it's 1 over x plus 3 plus 1 over x is equal to the combined rate, which is 1 over 2. And then you'll multiply through by the LCD and solve the equation. Oh, and I just reread the question. It actually said to use the variable t. So I should have been using t for, right, an equation that can be used to find the time t it takes Marcus to drain the pool. Using only the large hose. So it actually told you to use t for just the large hose, which I assigned x to, but should have been t. But either way, you get the same final answer. Thank you.